Welcome to section 4.2, trigonometric functions. We're going to do this on the unit circle, and this is part 1. What is a unit circle? And we're going to describe this relationship to real numbers, and also we're going to start evaluating trig functions using the unit circle. So first off, what is a unit circle? Well, it's 1 unit in terms of the radius. So it's a circle with a radius of 1 unit. We're going to look at the 6 trig functions on the unit circle. So what does that mean? Well, if we draw an angle, and theta represents that acute angle with the x-axis, we see that the r is the radius of the circle. Well, we know therefore that that value is then 1, so that represents 1 unit, so r is equal to 1. And then x is on the x-axis and y is on the y-axis. So this ordered pair on the unit circle is x comma y with a radius of 1. So what is our 6 trig functions based on that then? Well, sine is opposite over hypotenuse. The hypotenuse is the radius of the circle, which is really just 1 on the unit circle. So therefore, y divided by r, or y divided by 1, is just y. Cosine is adjacent over hypotenuse. Same thing, it's x divided by r, but x divided by 1 is x. And then tangent is opposite over adjacent. And so that gives us y over x. Cosecant would be the reciprocal of sine, so that's 1 over y. Secant's the reciprocal of cosine, so that's 1 over x. And then cotangent's the reciprocal of tangent, so that's x over y. Now, as we look at this a little bit closer, pay attention to the ordered pair on the unit circle, xy. What is another way that we can write that ordered pair on the unit circle? Well, x represents the cosine of theta. So here's x, represents the cosine of theta, and y represents the sine of theta. So this ordered pair we could rewrite as that represents whatever cosine of theta is, and y represents sine of theta. So that ordered pair on the unit circle will always be cosine theta comma sine theta, as long as you're on the unit circle. Now, if you're not on the unit circle, that ordered pair would represent something different. It wouldn't be cosine sine. So as we move forward here, we've got to remember that this is on the unit circle that we're talking about. We're going to look at our 3 special right triangles again. We'll start with 45, 45, 90. 45 degrees, that is a fourth of 180, so that's pi over 4 radians. We're going to draw the triangle on the unit circle, approximately where 45 degrees would be, or pi over 4 radians. We know that the hypotenuse is 1, and we did this earlier with triangles, but we are going to change the hypotenuse. Instead of being what it was earlier, it's going to be 1. And so what are our side lengths then? Well, x squared plus y squared is equal to r squared. But with a 45, 45, 90, those side lengths are the same. So we know that this would actually be 2x squared is equal to 1 squared, which is just 1 divided by 2, and that's 1/2. And then if you take the square root of that, that would be the square root of 1 over the square root of 2. So that's 1 over the square root of 2, which, if we rationalize the denominator, that's square root of 2 over 2. So this length is square root of 2 over 2, and this length is square root of 2 over 2. So the ordered pair, which is what we're trying to find, represents the square root of 2 over 2 and the square root of 2 over 2 for that 45, 45, 90. And so for all 45, 45, 90s, as long as you're on the unit circle, will always be square root of 2 over 2, comma, square root of 2 over 2. So that ordered pair is what we want to remember for our 45 degree angle. So 45 degrees has an ordered pair of square root of 2 over 2, square root of 2 over 2. So this is going to be important as we move forward. So what's sine of 45 degrees? Well, we know sine on a unit circle represents the y value. Well, what's the y value of our ordered pair? Square root of 2 over 2. Cosine represents the x value. What's the x value of the ordered pair for a 45, 45, 90? Square root of 2 over 2. And then tangent, we know, is y over x. But we also know that tangent, one of our identities that we have talked about, is equal to sine of theta over cosine of theta. So that's y divided by x. So if we take square root of 2 over 2 and divide it by square root of 2 over 2, what do we get? 1. And so if you go back to that triangle, you can see that when we take y divided by x, they're the same thing, so it equals 1. And then we can do the reciprocal of each of these. So cosecant would be the reciprocal of square root of 2 over 2. And since we had to, if you look back here, we actually had to reduce and rewrite it as by rationalizing the denominator. So it was 1 over the square root of 2. So if we take the reciprocal of that, that's just square root of 2. Same thing for secant. And then cotangent, the reciprocal of 1 is 1. Or you could flip it around and remember that cotangent of theta is equal to cosine of theta over sine of theta, which is x over y. So either way is fine. So there's the 6 trig functions for our 45, 45, 90 on the unit circle. And once again, we're using this based off the ordered pairs. This is true for any 45, 45, 90. These ratios will always be the same. All right, let's move forward and look at the 30, 60, 90s. We'll start with 30 degrees. So 30 degrees will be right there. The hypotenuse is 1. That radius is going to be 1 of the circle. So going back to our 30, 60, 90 triangle, if our hypotenuse is 1, our short side is half the hypotenuse, and then the long leg is the square root of 3 times the short leg. So square root of 3 times 1/2 would be square root of 3 over 2. So that leads us to this side being 1/2. This is the long leg, so that's square root of 3 over 2. And so that ordered pair for a 30-degree angle is going to represent x, so that's that's square root of 3 over 2, and then the y value, which is 1/2. So this ordered pair for 30 degrees is going to be that important part that we want to look at. We want to remember that ordered pair that we just created. And so in radians, 30 degrees is a sixth of 180, so that's pi over 6. So now we can go through and once again find each of the 6 trig functions. So sine of pi over 6, sine is the y value, so that's 1/2. Cosine is the x value, that's square root of 3 over 2. Tangent is y divided by x, or sine divided by cosine, so 1/2 divided by square root of 3 over 2 is the same thing as 1/2 times the reciprocal. So the 2's cancel and it's 1 over the square root of 3. And when you rationalize the denominator, it's square root of 3 over 3. And then for the cosecant, secant, and cotangent, you take the reciprocal of each of those. So the reciprocal of 1/2 is 2. The reciprocal of square root of 3 over 2, once it is rationalized, is 2 square roots of 3 over 3. And tangent, we had 1 over the square root of 3 before we rationalized it. So if we take the reciprocal of that, that'll give you the square root of 3. And so those are the 6 trig functions for a 30-degree angle. So 30 degrees is the ordered pair square root of 3 over 2, comma, 1/2. All right, so now let's look at the 60 degree. So 60 degree will be more up here. It still has that hypotenuse or radius of 1. The short side now, since 30 is up here, is on the x-axis, so that's 1/2. And then the long side is the square root of 3 over 2. So the ordered pair for a 60 is very similar to the 30 because it's the same triangle. It's just now that the x value is 1/2 and the y value is square root of 3 over 2. 60 degrees is a third of 180, so that's pi over 3. And then these values you're going to be seeing are very similar to your 30 degree because we're dealing with the same triangle. It's just now we're looking at different ratios because we're looking at a different angle. So sine of pi over 3, sine is your y value, so that's square root of 3 over 2. Cosine is your x, that's 1/2. And then tangent on this one, you're going to take the square root of 3 over 2 divided by 1/2. So that's square root of 3 over 2 times 2 over 1. And those cancel, so that gives you the square root of 3. And then you have your reciprocal. So we already did the reciprocal of square root of 3 over 2. That was 2 square roots of 3 over 3 when you rationalized it. And then reciprocal of 1/2 is 2. And reciprocal of square root of 3, 1 over the square root of 3 is equal to square root of 3 over 3. So looking at the 30 degree and the 60 degree, we didn't have any new values, just a new angle, so the values were moved around a little bit. So for 60 degrees, or pi over 3 radians, the ordered pair that we want to remember is 1/2 comma square root of 3 over 2. So once again, those 3 ordered pairs for 30, 45, and 60 are what we're going to be using to find the exact value of all our trig functions. All right, we've already talked about coterminal angles, angles in standard position with the same initial and terminal side. So here's your initial. And then if we do pi over 3, that's about a third, so that's right up here. So pi over 3. And then if we want to do a coterminal, we can add a full rotation to that, or we can subtract a full rotation. So to find the coterminal, you take pi over 3, and you add or subtract 2 pi to figure out 2 angles that are coterminal. So find a common denominator, so that's pi over 3 plus or minus, times the top and bottom by 3, so that'd be 6 pi. So pi minus 6 pi is negative 5 pi over 3, and then pi plus 6 pi is 7 pi over 3. So those are 2 angles that are coterminal to pi over 3. But it still gets you back to that angle right here. So that still represents pi over 3 radians. So that would represent which ordered pair? Well, pi over 3 would represent 1/2 square root of 3 over 2. So even if we have pi over 3, 7 pi over 3, negative 5 pi over 3, it still gets us back to that same angle that we'll be using to find the exact values. So now what I want you guys to work on is just finding those exact values. We're only dealing with quadrant 1 today, but you also have to deal with coterminal angles to figure out where they're located. So if you have cotangent of 45 degrees, what I want you to think about is what is that ordered pair for 45? And write it down every single time so you know what it is. So cotangent of 45, our ordered pair is square root of 2 over 2, comma square root of 2 over 2. Cotangent is x over y because it's the reciprocal of tangent. And remember, tangent sine over cosine, which is y over x. So cotangent would be x over y, which square root of 2 over 2 divided by square root of 2 over 2 is 1. 60 degrees. 60 degrees is the ordered pair 1/2, square root of 3 over 2. Cosine represents the x value, so cosine of 60 degrees is 1/2. Secant of 30 degrees, so 30 degrees has an ordered pair of square root of 3 over 2, comma 1/2. Secant is the reciprocal of cosine. Cosine is x, so 1 over x. What's 1 over x? Well, it's the reciprocal of square root of 3 over 2, so that's 2 over the square root of 3, which is 2 square roots of 3 over 3. And that's kind of the way I want you guys to think about this as you're going through and starting to work on these exact values. Sine of 390. Now, 390, we can actually take 390 and subtract 360 degrees, and still get sine of 30 degrees. So our 30-degree ordered pair is square root of 3 over 2, 1/2, and sine represents the y value, and the y value is 1/2. Tangent of 9 pi over 4. 9 pi over 4, now if you think of that number 9/4, that's 2 1/4, so that's more than a full rotation. So we need to take tangent of 9 pi over 4 and subtract 2 pi. So with a common denominator, that would be 8 pi over 4. And so that leaves us with tangent of pi over 4. So pi over 4 is an ordered pair of square root of 2 over 2. And tangent is y, or sine, over x. So that's y over x, which would represent 1. And the last one we're going to look at is cosine of negative 315. So with negative angles, you just want to add 360 back onto it. So if we don't want to deal with negative 315, we can just think about if I take negative 315 degrees and add 360 degrees, that will give us cosine of 45 degrees. So 45 is square root of 2 over 2, square root of 2 over 2, and so cosine is the x value, which is square root of 2 over 2. Now on my notes here, I put what each of the ratios was when I was going through that. You don't need to necessarily do that. I was just doing that to kind of show you where each of those values were coming from. Now on this last slide, just to kind of speed things up, instead of going back through each one of these again, these are just expressions. So instead of just finding one of them, you're finding multiple ones and just doing a little bit of algebra with them. So sine of pi over 4 is square root of 2 over 2, and cosine of pi over 4 is square root of 2 over 2. So if you then have to multiply those two together, that would give you the square root of 4 over 4. So that would be 2/4, which simplifies to 1/2. On number 9, it's 2 square roots of 3 over 3 plus square root of 2 over 2. Find that common denominator of 6, so multiply by 2. That'll give you 4 square roots of 3 plus, times top and bottom by 3 square roots of 2. Now you can't add radicals if they're not like, so this would be 4 square roots of 3 plus 3 square roots of 2 all over 6. So that would represent the exact value of that expression. And then on number 10, when you square root of 3 over 3, so that'd be 3/9. So you square root of 3, which would be 3. 3 squared is 9, plus square root of 2 squared would be 2, and then 2 squared is 4. So 3/9 plus 2/4 would represent 1/3 plus 1/2. Find that common denominator, so 2/6 plus 3/6 would equal 5/6. So just working still with the exact values, but then just a little bit of operations with them.